Hi there, you're welcome back to my channel. In this video, we're going to solve a problem on Gauss-Seidel method for solving systems of equation. In our previous lessons, we've gone through Gauss-Seidel method, Jacobi method, and we are still moving. So this is a problem on Gauss-Seidel. We've already talked through the concept a while. If this is the first time you've been on this channel, kindly subscribe to support and please watch this video to the end. So given the systems of equation here, 12x1 plus 3x2 minus 5x3 equals 1, x1 plus 5x2 plus 3x3 equals 28, 3x1 plus 7x2 plus 13x3 equals 76. Find the solution given that x1, x2, x3 which is equal to 0, 1, 0, 1 as the initial case. So you have to perform 3 iterations, okay? So let's see. So I explained that the goal of Gauss-Seidel method is that it's an improvement on Jacobi, and it is to speed up what rate of convergence, or to speed up convergence. Let me make it to speed up convergence. Okay, so it is purposely to speed up convergence, so because we want to speed up convergence, that is why we are trying to upgrade the method of Jacobi so that we can approach our exact answer as quick as possible. So to start with Gauss-Seidel method, the first thing to do is to make x1, x2, and x3 the subject, okay? But it follows the rule. The rule is that the coefficient of each variable, before you make each variable the subject, you know that there is x1 here, there is x1 in each of the equations, right? There is x2 in each of the equations, there is x3 in each of the equations. So how do I make the subject? Okay, which one should I make the subject? That is the confusion here, right? So for the purpose of convergence, it's always advisable to make the variable, okay, the constant here, sorry, it's always advisable to make each unknown with the highest coefficient. Okay, so here we have 12x1, right? We have here x1, we have 3x1, so this has the highest magnitude, so you have to make this one instead the subject, and in order to speed up the rate of convergence. Okay, when you come to x2, you realize that you have 3x2, we have 5x2, then we have 7x2, right? So we have to choose what the biggest among them. Okay, you have to choose the biggest among them, and that is the concept of what, the concept of diagonally dominant, diagonally okay, diagonally dominant. Then let's see, when you have 5x3, 3x3, 13x, you can see that 13x3 is the highest among them. So the diagonally dominant is saying that for every row, okay, for every row, your variable that you're making the subject, it should be the one with the highest magnitude for every particular row. Okay, so the reason why I was comparing columns is that, first of all, the column will guide us to this one. You know that it's having the highest, right? Having the highest, so we should move straight to this side without coming to consider this side. So once I know that 12x1 is the x1 with the highest sort magnitude, with the highest coefficient, and among all the others, this is 12, this is 3, this is 5. So meaning that if I'm to write the coefficient matrix here, I'll have 12, 3, 5, right? I'll have 1, 5, 3. I'll have 3, 7, 13. We realize that 12 here has a maximum magnitude within this row. You realize that 5 has a maximum magnitude within this row, and you realize that 13 has a maximum magnitude within this row. Okay, so this is what we call diagonally dominant matrix, and every diagonally dominant matrix should satisfy what, the absolute of what, your AII, right, whether A11, A22, A33, should always be greater than or equal to the sum of what the others, right? The sum of what the other entries. So the other entries here, okay, the sum of the other entries, maybe your AIJ, something like that. So I'll properly treat diagonally dominant matrix in a special section. Okay, so without wasting my time, let's go straight to solving our problem. So for this one, our equations has been ordered in the diagonal matrix form already, right? So I'll simply make S1 the subject from the first equation. So my X1 from the first equation will be equal to, I'll simply send everything there. So I'll have 1 minus 3x2 then plus 5x3 all over the coefficient of x1, which is 12. I'll have x2 to be equal to x2. I'll make it the subject. This one I'll make x2 the subject. Okay, so I'll have 28 minus x1 minus 3x3 all over what the coefficient of what x2, which is what 5. Then I'll have x3, which is equal to, for x3 I'll have what, I'm making this one the subject, right? So I'll have 76 minus 3x1 minus 7x2 divided by the coefficient of x3 here, which is what, 13. So once I have this, I've made this one the subject, the next thing to do is perform your iterations. Okay, to perform your iterations. So with the iterations, I'll draw an iteration table here. So let me draw an iteration table. Okay, so in the iteration table, you have the iteration, so the iterations you have, you are doing only 3. So first iteration, you have our second iteration, then you have our third iterations, then that's all. Okay, so we just have this here. So with first iteration, I always have, for every first iteration, this is the first iteration, this is second and third. So for every first iteration, you will have x1 value, right? So x1 of k value. Then I introduced a concept called the absolute relative error, right? So it's also calculated at each step to identify the error. Mostly for examination purposes, you'll be asked to calculate that. Okay, you'll be asked to calculate that. So error 1 in percentage. Okay, then you have your x2. You have your x2. Okay, then you also have another error again, absolute approximate error. It should be relative. So this error 2 is here. Then you have our x3. Okay, then the last error will be here. Okay, so once I have this iteration table, I'll simply compute my iteration. I'll come and fit in the values. Okay, so for the first iteration, I simply have to what, find the values, the new values of what, x1. So original values x0, let's say x0 is now what, giving us 1 0 1. Transpose, the transpose means that we are trying to find it in this way, 1 0 1. Okay, as to the normal, because we'll be using it most in this form. So now for our x1 value, our x1 value is simply equal to the first one. You just take this equation and put in our original value. So I'll have 1 minus 3 multiplied by x2 is 0, right? That's the current value we have. This is Gauss-Seidel, so we always use the current value. So 5 multiplied by here is 1, right? All over 12. Is that not it? Yes. So for our x1 value, we are going to get, so for our x1 value, we are expecting 0.500. So this is going to give us 0.5000. So we are leaving our decimal place to 4. It should be consistent. Okay, what you choose should be consistent, and 4 2 will guarantee you to getting your right answer. Okay, so then I move to x2. My x2 is equal to, when I come here, 28 minus my x1, which is what? The current value of x1 is what we put here, okay, minus the current value of x1, which is what? 0.500. So let's make it 0.5. Then you have minus 3 times x3. The only current x3 is what? 1. Simply write 1 all over 5. And what is x2? So our x2 is simply 4.90. 4.90 or 000. Okay, yeah. So once I have this, I move to x3. x3 will be equal to 76 minus 3 times our x1. And what is our x1? Our x1, the current value is now 0.500 in our table here. So 0.5, right? 0.5 minus 7 times our current x2 value, which is also 4.9. 4.9 all over 13. And this is giving our x3 to be 3.0923. 3.0923. So once I have this first iteration values, you can calculate for the absolute error. Okay, so for the absolute error, it's relative to what? We call it absolute relative error. Okay, relative to our answers, what are the errors or the change in what values? We are trying to iterate to convert to a particular answer. So the idea is that we are just to find the errors at each point, because there is deviation from the actual answer. But we don't know the actual answer. That's why we find relative errors. So relative to our even initial value, what was the error, right? So initially we started with 101. We started with 101, and with 101, we have got our new x value as 0.5. So the error is calculated as the current value 0.5, the absolute of the current value 0.5 minus the original value, which was 1, right? All over the current value 0.5 times 100. Okay, so this is how we do the calculation. This is how we do the calculation. Your original value minus your current value, which is now your present answer, minus the old one, all over 0.5 times what? 100. And here will give us negative half, and it will be what? 1. So obviously we are going to get what? 100%. Okay, 100%. Then you simply write it here, 100%. As simple as that. As simple as that. So you do same for each. Okay, so this one is going to be 4900. So I'll clean here, and I'll have here to be equal to 4.9, right, divided by what? 4.9 divided by 4.9, and this should give us, so if you have 4.9 minus 1 all over 4.9, you have times 100, and that's giving us 79.59. 79.59. Okay, so we are getting 79.59. So x2, so we are having 79.59. So it's in percentage. It's in percentage. It's in percentage. So let's see. You'll be repeating this for each entry, okay? But with the purpose of what? The timing of the video, I just have to focus on the iterations, okay? Just have to focus on the iterations. So with this iteration, I'll have my new x1 values, right? So I'm done with my first iteration, okay? So what will be my second iteration? my second iteration, I'm going to put the current values of our x1, x2, x3, which is 0 0.5, 4.900, then 3.093. Okay, so my x1 value is now 1 minus 3 times the new x2 value. The new x2 value is 4.9, so 4.9. Okay, the new x2 value is 4.9, then also plus 5 multiplying the current x3 value, which is 3.0923, all over the expression 12. Okay, so the value for x1 now becomes, in our second iteration, the value for x1 now becomes 0.14679. Okay, 0.14679. So this is the current value of x1 we've got in our second iteration. So we move on with the current x2. So the current x2, I'll clean my x1s here. Okay, so now I'm having x2 28 minus x1. And what's the current x1? We immediately use the current value we had here, which is 0.1467, right? So please use the calculator and punch as I go through with you so that you test the accuracy of the numbers. So, but first of all, you should understand the concepts, then you punch as well to get the values on your side. Yeah, so our x2 now becomes what? 28 minus 0.1467, then minus the current value of what? X3, 3 times. Our current value is what? 3.0923, right? So with that, we are getting the value for x2 to be 3.7153. 3.7153. Okay, then for the third iteration, I simply also make changes to, sorry, with the x3, I simply make changes to what I have here. So with the s3, I have 76 minus 3 times x1. What's the current x1? Is 0.14679, right? Then minus 7 times the current x2. Current x2 is now 3.713. 0.7153. Okay, so once you have this, then our current x3 is going to be, our current value for the x3 will simply be 3.8118. 3.8118. 3.8118. Now we finally move to the third iteration. So with the third iteration, my x1 will simply be, I have 1 minus 3 times our hot x2. Current x2 is what? 3.713. 3.713153. Then plus 5 times hot current x3 value. Current x3 3.8118, right? All over 12. And that is giving us 0.74275. 0.7428. Sorry, 6 instead. So I chose 4 decimal places, yes, but I wasn't obeying, so let's stick to that. So x2, for x2, I'll simply have the changes made here. So for our x2, I'll simply have 28 minus my x1, and my current x1 is 0.7426, okay, minus 3 times my x3. My current x3 is 3.8118. 3.8118. Okay. So with this, we solve for x2, and we'll be getting x2 to be equal to 3.16644. 3.1644. Then finally, we make changes to our current x3 here. So our current x3 will now be 76 minus 3x1. What's our current x1? 0.7426, right? Minus 7, multiplying the x2. So the x2 is what? Current one is 3.1644 divided by 13. And our answer will be 4 point, sorry, our answer is going to be 3.9 3.9708. 3.9708. So let me see, 76 minus 3 multiplying 0.7426 minus 7 multiplying 3.1644, right? All divided by 13. 0.9708. So these are the values for our first, second, and or third iterations. The question says you should perform only 3 iterations. Okay. Yes. So this Gauss-Seidel method, it takes in the current output. Okay. So you can go ahead and fill all the empty spaces here. And that one I said is current value, right? Minus what? The immediate past, or you say previous value, previous, all over what? Current, absolute of this times 100. Okay, times 100%. Or you can also say that x to the power k plus 1, right? That's your current, minus x to the power k all over x to the power k plus 1 times us 100, absolute of this, right? Times 100%. Then that's all. That's all. Thank you for being with me in this video. Kindly subscribe to support, and don't forget to like and share.